All right, we have 3 more talks left, and one of them is by Marco Maronjo.
Quite good for a
He told me that
non-Italian.
nobody can pronounce his name, so I'll just give it one shot. So he's going to talk about some more advanced topic, external node classification, and a comparison between Puppet and CF engine. So go ahead.
Thank you. Actually, since they squeezed me in 25 minutes, I will have very little to nothing to talk about Puppet, but I will try to do something. And I'm not going to talk about myself. I'll give you some pointers. So if I'm an interesting person, you will have to check by yourself. So what I'm going to talk about today, why the classification process in configuration management is critical, why it's also difficult, and how we can make it sane, and some final takeaways. So part 1, the problem. Since configuration management is the theme of this dev room, everyone would be expected to know the definition of it. But actually talking about the definition of configuration management, maybe it's a bit hard, because there are so many tools around and claiming to do configuration management that if one tries to infer the definition by how his own tool does things, then it becomes a bit confusing. Everyone is doing things differently. So I looked for a definition by Mark Burgess, who started everything, only to find out that him in turn refers to IEEE. This long definition. Configuration management is the process of 1, identifying and defining the items in the system. 2, controlling the change of these items throughout the life cycle. 3, recording and reporting the status of items and change requests. And 4th, verifying the completeness and correctness of items. Now, if we had to talk about this, every single piece of this, and discuss about how each of these tools does or doesn't that part, it would take hours. So for my part, I will concentrate only on this first part, the process of identifying and defining the items in the system. It's not an accident that this part comes first, because doing anything that comes after that part would be impossible if we didn't identify the systems first. So this process of identifying the systems to see what their characteristics are, like their location, which data center, or which networks it is attached to, which processes it runs or must run, must not run, you name it, is often referred to as classification in configuration management. And when we classify a node, we see its traits in a way, and we make broad sets of systems that share a common trait. Only after you correctly classify a system, you can configure it, or if you prefer, you can make it converge to the state that it should go to. And that's an important thing, because in configuration management, you don't configure systems. You apply configurations to classes of systems. You see that this presentation is rather wooden. Now you can start to understand why. So a node can be effectively managed only if it's tied to the classes that define its characteristics. This makes classification a critical process. It either scales with your infrastructure, or it's a hindrance to its growth. Okay, we have seen the problem. Now, what are the challenges? Where settings, the main challenge, as you have seen even in the talk before mine, is that settings are supposed to be homogeneous across all systems in a certain class, right? Like a web server is a web server. However, there are nodes that are part of a class and yet need some small settings different from every other node in the same class. You know better than me, if you have hit your head on a wall many times, exceptions are the rule in classification, in configuration management. So let's try to see with a concrete example. Now think of your infrastructure, the one you left at home, at work. I expect it to have some generic settings. You to have some generic settings that you apply everywhere and don't depend on the location or anything else. And then, for example, you have settings that you apply to all the nodes you have in Amsterdam, let's say, and are supposed to be the same. Like in Amsterdam, all the nodes will point to the same DNS servers, right? All the nodes? Well, wait, not the two DNS servers. They will point to themselves from the loopback interface as a first choice and to the other one. So, damn, two exceptions. And NTP configuration, it will be the same on all nodes in Amsterdam, right? All nodes, but maybe the 4 DNS servers that will point to other machines upstream will have other restrictions. And what about syslog? All nodes will be syslog clients. No, wait, there is one that will not point to itself, or well, what will it do? Okay. And what about SSH? Now starts the mess, because you have maybe a general policy, no root logins, no password logins, authorized keys in the home directory .ssh. And then you have some nodes where you need to have root logins, password logins, so all these things mixed. So you start having tons of crap and other random stuff, and other locations will be the same or even more complicated. Like you have private addressing, public addressing, machines on either side or on both sides, and on each of these 3 subsets, exceptions everywhere. Do you see it in your infrastructure? Okay, I see some people nodding. Yeah, that's quite common. It's not an exception anymore, it's a rule. So how can you cope with this? Can you cope with this just by the configuration files of your configuration management tool of choice? Well, you can try. But it doesn't scale, and it doesn't for it generates at least 3 problems. At least 3. The first one is definitions explosion. So you have, okay, this is the settings for class A. And then, oh, I have an exception. So you have class A, but not exception A, and then you start pouring codes, a code. It becomes big, it becomes harder to read, it takes longer to parse for the tool. Not good. Another thing, difficult reporting. So you are going to make a change to the nodes that belong to a certain class. Good. And you want to know which nodes exactly, the list of the nodes that will be impacted. And since you made a mess in your policies or manifest or recipes, you know your tool, you have to go through all the exceptions to know how easy is it. It's not. And the last one is the human bottleneck. Now I'm stealing the words of another person in the CF Engine community, but basically, if all the information is in the policies, then everyone that needs a different class or to change the members of a class or whatever has either to know how to configure your configuration management tool or has to come to you to ask. And if this happens often, you are a bottleneck. So we could discuss more, but there is no time, so I have to go straight to the solutions. So the solution, what is the solution? In general, you need a configuration database. A configuration database that is outside of your policies, that has an interface for you or for other to put information or take information. And then you have another problem, and you have to plug it to your configuration management tool. Obviously. So how do you decide what's the right interface for it, for your configuration database? And how sophisticated should it be? Well, it can depend on many things, but if we go down to earth, it's probably just 2, well, at least 2. The technical skills of your customers, if you want to call them, and how your infrastructure is complex. If your customers are well-versed technical people, they are happy even with plain text files or running SQL queries, no problems. They don't fear it. But if you have like salespeople, then probably they want a nice, pretty web interface, and so forth. So we'll see, depending on who your customers are and how complex is your infrastructure, your solution will end in one of these 4 quadrants. We'll see 2 solutions. First, the solution that was built in LinkedIn, it is in this quadrant. And then the solution that we built at Opera that is in this quadrant, so the 2 extremes. Let's see the first one. I'm stealing one slide from the presentation of Mike. What they did in LinkedIn, they have some massive installations there. Well, they created a data collection system that is integrated with CF Engine in this case. And they use it to populate a distributed cache that's based on Range. Range is a product, open source product from Yahoo. They populate this cache that is always up to date, can be queried in seconds or minutes, not hours. And this system doesn't even need an inventory because it's itself an inventory. And plus, they use it for classification of the nodes, and they use for reporting, and they also have an interface that allows other people to define classes across their clusters. So it's a quite sophisticated thing. It's in this presentation that you see here at the bottom, and there is a video on YouTube, so you can have all the details there. So as beautiful and sophisticated this solution was, it was maybe a bit too much for my needs. What did I... Okay, it took the photo, now I can go on. So how was our implementation? What did we want from external node classification? Well, it was 2 purposes mainly. The first one was allow us to scale better, of course, like all ENC, but by making it easy to manage exceptions. It's a main problem. And the second was to take configuration information out of CF Engine policies and to something else that is easier to handle for sysadmins. So plain text files in our case. So it's not really an approach that is close to LinkedIn, it's close to other approaches, but I think we found the right combination of power and simplicity. So we take configuration information in plain text files, we use the CF Engine module protocol and a simple Perl script to do hierarchical classification like here in Puppet, basically. And you will see that there is no rocket science here, nothing like that. It's a, how much?
10 minutes, sorry.
Thank you. Okay. But this allowed us to cope with a sudden growth in managed nodes at the end of 2013. We started with applying some security hardening on SSH with this, and then we used it to implement centralized and distributed rsyslog infrastructure, and other things have been done, run in the pipeline in active development. So we mentioned modules, CF Engine modules. Anyone that doesn't know CF Engine modules? Okay, good. Just to know how fast I have to go. I'll go slower. So CF Engines are programs that are run from the CF Engine agent to collect information from outside, information that the agent couldn't tell by itself. And they can do whatever they want to collect information. They can be written in any language on the planet, but they have to return the information to the agent, printing something on the standard output with a very simple format. Plus something, for example, plus activated class creates a global class called activated class. While this dash something cancels a global class. This defines a scalar variable. This defines a list of 4 values. And one can also define array elements. And there are also extensions in the latest versions of CF Engine, but since we don't use one of those versions for now, we don't talk about them, but you can see the documentation, and it's easy to extend the mechanism. So, what would happen if we had a set of files that are formatted exactly like this? We could just run on Unix system cat those files from inside the agent and get information. That would be something very simple, but would be really bad because we couldn't put any meta information in the files, so we couldn't document anything. But there is a quick fix for it, right? A wrapper around grep, 1 line, it's easy. But this doesn't fit the bill either. Is anyone, I give you 5 seconds to see what's the problem here. 1, 2, 3, 4, 5. The problem is that if you use it on many files, you could set conflicting settings, like define a class and cancel a class in another file. Define a variable like a scalar variable, and in another file it's an array. So it doesn't work like this. You can predict what comes out of it. You need to merge this information in something coherent. So if a class is defined here and then later cancelled, it must be cancelled, and the first definition must go away. How hard is it to write something that does this merge? Well, I'm not telling anything, just judge by yourself by the length of this per script. It's a bit cut from one side, I'm sorry. But this script does exactly that. It tries to locate what kind of resource we are trying to define, and it cancels or creates classes depending on what sets it and when it sets it. In a way, it's like this toy, where you have different layers, like different files to read the information from, and the image you see by looking above it is a merging of what has been not overridden of the lower layers. So this is fine, but there is still one piece missing. How we decide the list of the files that must be read, and what do we want to read? In our case, we decide for something not too difficult. It could be a fixed list. It could be something that we get from outside running a program or whatever. We got something, again, in the middle. We want to read just 4 layers. Some general defaults, generally valid for all locations. Then something that depends on the location and can override the general. Then something on this location that depends on the environment in that location. Like, I have a private address, I don't have it. And then some node-specific settings. So be able to override settings even at the node level. We define this hierarchy of files. How we build it? Well, we have classes for each location that tell us where we are. For example, Oslo. And we have other classes that tell us environmental information. Based on that, we build some variables, and finally we build a list with general default first and then location environment node. And when we have these lists, we pass it to a bundle. This is the name of the list, the full name of the list. And it reads, it defines the classes, it defines variables. And once we have all of this, we can use it everywhere. So if we can define, for example, the DNS server addresses like this, how hard is it to just override those few settings in 2 DNS servers? You create a file with 2 different variables, that's all. Or NTP servers again, or syslog. Anything. It's not terribly hard, right? So I can't go much farther, so we have to go to the final takeaways. So you need I tried to show why classification is crucial and why it requires an adequate tool to allow you to scale. But it doesn't need to be too complicated. As we have just seen, even sometimes, depending on your infrastructure, plain text is good enough. So other shops have implemented very sophisticated things like LinkedIn. Our solution is probably the least sophisticated of the pool, but it allows us to cope with, as I said, a sudden increase in the number of nodes managed, and we trust that it can help us to scale a bit farther in the future. Any questions? Not IKEA questions, I'm not good, but about this talk. Yes?
How big is your infrastructure then?
Sorry?
How big is your infrastructure then?
Okay. So far, the last time I counted the nodes, it was more than 300 managed nodes. It's not big. The problem with that is that it went from around 50 to 300 in a very short time. And it needed to have something to keep. Now it's going at a much lower pace, but since other people are starting to see how useful it is, I expect it to grow faster again. It is not big. Well, the infrastructure is big, but the number of managed nodes is not that big now. Yes?
What tools do you use to populate the text files you read and inventory tools?
How do you manage it?
Okay. VI, Emacs, and Git. No, they are together with the policies for now. Because as no one but the sysadmins are working on these policies, there is no need for us to, for example, interface with sales, for example. So for now, the solution is good enough, just keeping everything in the same Git repository. Okay, these are my contacts. If you have any comments, good, bad, if they are constructive, I accept everything. Even just stop talking and I won't give any more talks. And if you want information about me, I didn't give any. This is my professional blog and this is my LinkedIn profile. Thank you.
Thank you, Marco.